All right, it's that time to start graphing trig functions. I know I'm excited, so let's get going. Trigonometric functions are called periodic because they just repeat the same values in regular periods over and over and over again. I've got one graphed out here in front of you. Note that it just makes this up and down, up and down, up and down wave forever. So again, we call that behavior periodic. The period is how many degrees are needed to complete a full cycle. So if you think about starting at 0, going all the way up to the max value, all the way down to the min value, and then back to start, that's called the period. How many degrees needed to do that? Get all the values that this function has to offer and come back to start. So that takes 360 degrees for our parent functions. And if you're thinking about that, a circle is 360 degrees. So we're talking about starting at 0, going all the way around the circle, and then coming back. The reason the functions are periodic is you could think about angles that go beyond 360, 361, 362, 363, forever and ever and ever, amen. If you've ever done any skateboarding or watched any X Games or anything, you'll see him talk about doing a 720 or a 1080. That's just going around the circle over and over and over again. And note, when you do that, the same values just get repeated over and over and over again. So in Algebra 2AB, we mostly just focus on that first period, that first chunk of values. If you choose to take some classes beyond Algebra 2AB, you will play around with some of those negative angles, some of those angles bigger than 360. You'll go quite a bit further than we will here. The last chunk of vocab is amplitude. And amplitude's a word that you may remember from ICP or physics if you took that. Amplitude is half the distance between the min and the max values. So in our parent functions, that max value will be a 1, that min value will be a -1. You can see those points as the high and the low. So the total distance there is 2. Half of that distance then is 1. All of the graphs we are going to look at will have a nice center line at 0. So really the easiest way to see that amplitude will actually just be measuring that distance there from the max down to that 0 or from the min down to that 0. So in our parent function, that amplitude is just 1. Let's actually graph these parents, get an idea of what they look like. So we're going to start with sine of x, and like with all of our graphs, we're going to start with a table. Now, I know you don't know what sine of 0 is off the top of your head, but your calculator can help you out here. Remember that we are in degrees for our mode, and mine is still set up that way. Make sure yours is as well if you're following along. I'm going to look at sine of 0 as one of my critical values, and then the other critical values, if we go back to thinking about that circle, 0 is one of my criticals. The other ones that I'm going to look at are 90 as in 90 degrees, 180 is in 180 degrees, 270 is in 270 degrees, and then 360 back to start. Those are called critical values. So we want sine of 0, sine of 90, sine of 180, sine of 270, and last but not least, sine of 360, which ought to be the same as sine of 0, because 360 and 0 are the same angle. So there we have it. Now you'll always be able to use your calculator to help you get these values if you would like. Graphing them is actually going to provide a pretty nice pattern for us though. So we're going to have the point 0, 0, the point 90. I'm going to put my axes down here. 0, 90, 180, 270, 360. And then this will be -1, this will be +1. So I will have the point 0, 0, the point 90, comma 1, 180, comma 0, 270, -1, and then finally 360 will also be 0. These two should always match. Because the graph is periodic, its start point and end point will have the same y value. So we get that wave shape that we saw on the first slide. There we go. Not bad, not bad. The shortcut for sine is just to remember the order that these points go in. Sine starts in the middle, then goes high, then goes back to the middle, then goes low, and then comes back to the middle. So you can avoid running back to your calculator over and over again by just remembering that sine starts in the middle and then goes up. We're going to look at cosine, which will have all the same y values, but in a different order. So learning that order can help you save some time over jumping to the calculator. But there we have our parent function for sine. Now let's do cosine. Cosine is going to have those same critical values. Again, thinking about going around the circle, you're starting at 0 degrees, 90, your right angle is important, 180, your supplementary angles are important, and then 270, finally coming back to 360. However, with cosine, cosine of 0 is actually 1. So cosine is going to start high. And then we'll have cosine of 90, cosine of 180, cosine of 270, and then cosine of 360 ought to be the same as cosine of 0, and it is. So here we filled out our table. I'll again do the axes on the outside of the graph, 0, 90, 180, 270, and 360. And on the y-axis, we care about -1 and +1. So cosine starts high, and then goes to the middle, 90, 0, and then goes low, and then middle, and then high. So cosine has all the same numbers, they just show up in a different order. Cosine starts high, then goes middle, then goes low, back to middle, and back high. So there we have our two parent graphs, our sine graph and our cosine graph. We are going to go ahead and look at transformations. I'll do those in the next video. See you soon.